You have stumbled into All Space Considered at Griffith Observatory. Without further ado, let's get on and look forward into 2018. First let's look back at 2017 and what the big stories were there. Yeah, that was them. So obviously 2017 had a lot of major headlines. How many of you saw the total eclipse? Yeah, so, we've been telling you for 10 years, 2017, big year, go see an eclipse. That was a major story, Cassini crash, stories all over the solar system, stories on Earth, stories out in deep space. So we're just going to give you a quick rundown of some of the major things that happened in 2017. Of course, the eclipse, and loved seeing all those hands go up. Yay for you. If somehow you slept through 2017, you may not be aware that this eclipse passed across the entire continental United States, and just about everywhere had clear skies, except for poor Patrick, who did not. I'm sorry, Patrick. But just about everybody. Who else went to go see it and got clouded out? Oh, Patrick, I'm so sorry.
Am I a winner? No.
You're the winner. You can get a calendar.
Okay.
Where'd you go? Where was Patrick?
Kansas.
It was very busy here for those of you who couldn't travel. I know. We have a little video at break time showing you that from a helicopter, kind of very intense. There are several coming up, and I just put a couple of them in there because the next two go through South America in 2019 and 2020. So if you got the fever and you need to go see another one, you can go to South America on those dates and be somewhere on that line. I also put this 2021 eclipse in Antarctica. But the very important one for most everybody who doesn't want to go traveling to some other place on the globe is that we got another one coming across the United States. And so they cross the path of the 2024 path, crossed the 2017 path. And for those of you who remember the show, we looked to see, is there anything magical about that spot? And that's the spot, that's the location, and believe it or not, there's a house right there. So we haven't had a chance to go. We should do one of those like road trip shows and go see who lives there and find out. If you do go see an eclipse, please wear eye protection.
Yeah, unfortunately there was one 21-year-old woman who apparently didn't follow our directions right and looked at the sun. Her doctors think for maybe about 20 seconds, and we can see the results here.
20 seconds.
She claimed she was looking through a borrowed set of glasses that maybe were not right, but then she gave it back to whoever she borrowed it from, so maybe.
Oh.
But you can actually see the shape of the eclipse seared into her eye. This is a new adaptive optics retina image where you can see individual cells and you can actually see the damaged cells.
So please, please be careful. Get the right eye protection. You can get them here, get them in advance because there's always a run as it gets close. But you've got 7 years, or 6.5 years. There were a lot of headlines in planetary exploration. Perhaps the best known was the end of the Cassini mission. Is there, no, I'm not going to ask that. I was going to ask, does anybody here not know much about Cassini? But I'm going to go ahead and just say a little bit about it because Cassini has been at Saturn, the mission Cassini, since 2004, giving us all these magnificent, stunning pictures of Saturn and teaching us things that we absolutely had no knowledge of before. For example, that crazy hexagon at the top of Saturn's North Pole. Amazing things about the rings that are far more complex than we ever had any idea. A tremendous amount of physics in that about how particle fluids work. A lot about its 62 moons, and we studied many of them very closely. In particular, this moon, Enceladus. Yes, it is quite cold, but that's what makes it crazy, that there are these geysers of material coming out of the bottom, and they're coming out of these stripes at the South Pole that are actually warm. The one image on the right is in infrared, shows the heat coming out of that. So so Cassini actually flew through the little plumes there. I don't know if you can see the little tiny Cassini there. It's very cute. And I'm sure that's what NASA thinks of it too. And it found amazing things about what's inside of Enceladus. There's a global ocean, there are salts, there's evidence for hydrogen, which is on Earth a food for microscopic life. So it really has all the conditions and ingredients that are needed for life inside that little moon. So that is a very intriguing moon, and we want to go back and take a look at it a little bit more. Also intriguing is Saturn's moon Titan, which is that strange ball. This is a side-on view of Saturn, of course, and the rings are just that white line, although they cast the shadow. But that is Titan there, way outside the ring system, the largest moon around Saturn, and can't see much from Earth. But part of the Cassini mission actually sent in a little probe called the Huygens probe that went through the haze and imaged the surface, and lo and behold, we found that Titan is the most Earth-like world in our solar system. It has mountains and winds and riverbeds. It even has lakes. There's a lake district in the north. You can see the sunlight shining off the lakes in the north. So Titan, another crazy world, an ocean inside, but it's also got all these organics, all these hydrocarbons in the atmosphere and on the surface. So another really good potential target for looking for life. In April, the Cassini mission did a very daring move and went plunging in between Saturn and its rings. So imagine the precision of those flight controllers. You can see it just dropped from outside the rings to inside the rings in late April, and got these stunning pictures of the rings from right next to Saturn. Beautiful image of the very faint E-ring, actually. So even more dramatic than that and sad is that on September 15th, the little blue dot dropped all the way into Saturn's atmosphere, and lo and behold, we said goodbye to this amazing mission. So it's a very big event for 2017. Very sad to see it all come to an end.
Call us, the signal is 115546 for the S-band, so that would be the end of the spacecraft.
The end of the spacecraft. So we have NASA to thank for an extraordinary mission, and of course for this iconic picture where we're looking from the backside of Saturn and see the Earth and Moon and Mars and Venus. Absolutely beautiful picture. But Saturn wasn't the only planet we visited and spent time at it in 2017. We were also at Jupiter.
Yes, and spacecraft Juno, which is currently in orbit around Jupiter, made 7 close flybys of Jupiter, giving us the closest look at Jupiter's red spot. Also, looking out from Jupiter, one of its cameras captured the rings of Jupiter, and in the backdrop there is Orion. And its mission is ongoing, so it's continuing to send us fantastic images of Jupiter's polar regions, which have never been seen before when you look at the other image, and some of the bands. And I'll be covering a little bit more of these images later on in the last close flyby, which was Perijove 10 on December 16th.
Great. We also have spent a lot of time at Mars this past year.
Yeah, on Mars, Curiosity found boron. It got back to drilling. The RSL, the weird streaks we see on the sides of slopes were maybe sand flows, and 2020 landing sites. So let's take a look at some of this. Curiosity rover, of course, used its laser to analyze boron. It actually laser beam on me. Hey, careful with that beam. It vaporized a little material and found boron. You might wonder, well, why do we care about boron? Turns out boron's important for life, important for the RNA. And there is the element boron. Curiosity has a drill on board, which actually broke. After drilling all those holes, you're able to get down to the rocks and measure what they're made out of. Well, it broke, but they managed to solve that. So it'll get back to drilling in the near future, and we'll be able to continue to analyze rocks. Here are those recurring slope lineae, those streaks that you see grow. They appear in the springtime, and they disappear in the late summer. People thought maybe it was water flowing. There is evidence that there's some water there, but also there's evidence that these were caused by sand flows, because they happen only at very steep slopes where you'd expect sand to be able to fall downhill, and where the slope changed and wasn't steep enough, the RSLs end. So pretty strong evidence that they're just sand flows. They're sending another rover in 2020 to do more investigations and actually gather samples, maybe to send back to Earth one day. And the 3 landing sites were chosen. You can see there, Jezero Crater. It's inside a crater where you can see deposits from rivers that were flowing in, deltas. Northeast Syrtis, which is actually a hot spring, or Columbia Hills, which has also hot spring activity. Hot springs are interesting because maybe life could have formed there. But they're going to narrow down the selection, hopefully, coming up.
Before we leave Mars, how long is Curiosity supposed to still work? Do you know?
Oh, gosh. I don't know that answer.
Because it certainly will be in 2018. We'll certainly have plenty more Curiosity
Yes,
to go.
we'll continue to hear more about Curiosity. It's going to keep going up Mount Sharp and keep making more analysis. But I know that it has quite a bit of time left in it. It isn't solar powered. It's powered by the nuclear pack on the back. So it should have quite a bit of time left in it, as long as those wheels hold up.
Great. So it wasn't just the planets in our solar system. We also visited some of the icy bodies in our solar system. And if you've come here before, you've heard our icy body update. And also, if you've come before, you know we always like to show that, because who doesn't want to look at that cold, icy body? Well, maybe nobody wants to look at it, actually, come think about it. So let's look at this one instead. This is Ceres, a member of the asteroid belt.
Yeah, Ceres is in the asteroid belt. It's actually a dwarf planet, just like Pluto is. And it has that interesting spot on it called Ocketer Crater. It has a bright spot in the middle of it. In fact, they discovered that there's organic materials on the surface. This is consistent with Ceres being somewhat active recently. Material flowing up from deep inside. The ice is on the surface or being brought up maybe in an ice volcano. Here you can see the salt deposits left behind after water came to the surface, froze, and sublimed away. And here's that ice volcano they see on the surface where they think ice is kind of coming out the top of it and then tumbles down those steep slopes. So Ceres is an active body in the asteroid belt. Very, very interesting.
And also, in the outer solar system, one of Jupiter's moons, Europa, is a nice icy moon. And you can see it has these cracks because inside Europa, like some of these other moons that we've been talking about, there is a liquid water ocean. Now, before we talked about Enceladus and flying through those plumes, it's very convenient for Enceladus to, send some of its insides outside so we can go study it. The problem with Europa is, how do you drill through all this ice to find out about the liquid water inside and find out if life might exist? Well, very exciting result in 2017 that actually mirrored some, in 2016 mirrored some 2014 results, that they saw tentative indication that there are water plumes coming out, but and it seems to be intermittent. Sometimes the water plumes are there, sometimes they're not. But in 2017, further analysis showed that same spot that does seem to keep erupting is also warm, just like those tiger stripes, just like that south pole of Enceladus. So there may be, in fact, a warm venting crack in Europa. Europa is much, much, much larger than Enceladus. And so if there's a liquid water, well, there is a liquid water ocean. If we're able to fly through that and learn more about the plumes, maybe we'll be able to determine whether or not Europa has the right conditions for life. So it's kind of amazing, all these right conditions for life in the solar system. I can't get over how much that perspective has changed over the last 10 years. We are sending a mission that's being constructed as we speak at JPL called the Europa Clipper. And there he is. It won't launch quite yet, but when it gets to Europa, it will look for and analyze more about these plumes. So speaking of icy bodies.
Yes. Earlier this year, we reported something that scientists were very concerned about was an iceberg that was about to break off in Antarctica called Larsen C. There's a photograph of it, and that's the location. This iceberg was several years ago. A crack began right here and then went all the way up here until through about April. There was only about 12 miles left. And this iceberg was hanging on the thread. It was just about to separate. The problem was that we didn't know when this was going to break, and also it was in the southern hemisphere, so winter was coming in the southern hemisphere. And we only found out that it actually separated from the main ice shelf in July from infrared photographs from Sentinel-1 satellite and other satellites. And so it broke in July, and this is the image taken in September when daylight returned to that region of the world. And now we have a gigantic iceberg.
How gigantic?
How big? Well, we can see in the next slide. It's about the size of Delaware.
It's a little bigger than that, but yeah,
Yes.
it's one Delaware in
Yes,
size.
exactly, which is floating in the Southern Ocean right now.
So, of course, that's not the only story of drama on Earth. We had quite a lot of interesting and extreme natural occurrences, earthquakes, hurricanes, fires, or as we were saying in our meeting the other day, earth, wind, and fire. I was trying to coax him to sing a little Earth, Wind, and Fire for you, but I don't know, maybe he will before the show ends. But, yeah. Some really great news in 2017 began when we started the year. We had this terrible, terrible drought. And I'm going to go through these very quickly because from January to the end of spring, it went away. Yay! And then stayed very stable through the summer. But it really just dumped a lot of rain on us. So, Patrick, what happened?
So this was basically brought about by a very strong El Nino condition, which is the warming of the Eastern Pacific, and produced a lot of evaporation, a lot of moisture, and winds basically brought in torrents of moisture into California called atmospheric rivers, as you can see from the satellite photograph. And the amount of rain that was dumped was tremendous, mostly in Northern California, Central California, causing dry rivers to turn into streams of torrents of white water rafting, if you will. The parched Central Valley, which is the mainstay of our agriculture for this state, was dry, very dry, brown, and there was nothing much growing in it. And then we had record snowfalls, and the snow accumulated up to 150% of normal at the beginning of this year, which was really good news for agriculture. You can see how green the Central Valley became.
And of course, we were very happy at All Space Considered because Patrick was reporting on this for many years, and now he has to learn how to surf, so we thought that worked well. So some of the happy outcome, of course, is we had one of the most beautiful flower blooms that we've had in California in quite a long time. It was just spectacular. How many of you got out to see that? It was breathtaking. On the flip side, it also led to mudslides, because we are California after all, and lost a little bit of PCH. I'm assuming that's been cleaned up by now. That was quite a while ago.
I don't think so.
Is it still closed?
They're actually going to build a new road.
What?
They're going to have to build a new road around it.
Oh my gosh, they're going to have to build a new road around it.
Million cubic feet.
Wow, I had just assumed that would be enough time, but that's the problem with assuming. You
It's
should
2
find
weeks
out.
for a tunnel, so they just have to build around it.
Wow, great news. 2 weeks for a tunnel, so they have to build around. That's pretty stunning. Well, anyway, that was one of the outcomes of our big storm. Now, of course, as fall goes on and the winter approaches, we're starting to get dry again. We haven't had a lot of rain, but it really has kind of stabilized, and it's not anything like it was a year ago. So this is good news. We've also had extreme temperatures. This was Phoenix last summer. I like the pancakes. It's actually 200 degrees inside of that car. Hot enough for water just to boil right off the manhole covers. So hot that they ran out of colors on the map for the temperature. It was all in the 120s. And of course, we had violent storms. Big hurricanes. Just to remind you what 120 mile an hour winds feel like. That's in St. Martin. Patrick, you want to say a little more?
Yeah, 2017 was a record year for the Atlantic hurricane season. We had 3 Category 4 hurricanes raging in the Atlantic, and 3 of them made landfall. And these were captured by our weather satellites. On the left there is our latest new generation satellite, GOES 16, which replaced GOES 13. And you can see how advanced that imagery is. It takes pictures every 30 seconds, and so gives us near real-time images of events like this. And this satellite has also replaced GOES 13. So
a big highlight of 2017 was to get a much better eye in the sky to look at these
yes,
things.
indeed.
Which hurricane was that, do you know?
That's Irma.
Irma. And just in case you've forgotten your different categories, we have this handy dandy guide of different category strengths. So these were Cat 5. I think you said 3 Cat 5.
Cat 4s.
Very windy.
And this is the aftermath of a small Caribbean island called Virgin Gorda, and it's you can see the before lush vegetation, and after 180-mile winds went through with the hurricane, it basically ripped all the vegetation away from the island.
And of course, Puerto Rico is still suffering with only about half the island has power still, all these months later. That's my sister-in-law's dog, so he made it through. So yay! And so did these folks. And the parrots on the right became internet sensations, so we just thought we'd share them with you. Then lastly, in extreme Earth conditions, big fires. This is the Burbank fire or the La Tuna fire. So it's always just a reminder of the extraordinary effort done by our firefighters who face this head on. I really like these guys in this airplane. I'm not sure I would want to be flying that plane. And of course the requisite bunny running away. He lived. It's okay. It's okay. Now we need the clapping rodent. Anyway, sorry. Something from earlier. Of course, one of the worst fires that we had was up in the Bay Area. Santa Rosa just went through devastating loss. So why was fire season so bad this year?
Well, first of all, we had the big rains earlier on in the year. And then after that, it warmed up, and there was a lot of overgrowth, of undergrowth. And then came the strong winds up there in north called Diablo winds, which basically fanned the fire out into a huge area. And unfortunately, there are subdivisions that are built in areas that are heavily forested, so they're kind of fire prone. And so there were a lot of structures, unfortunately, lost in that fire.
So a big takeaway, do not go out and have a cigarette as soon as you leave the building. Right? It's amazing how much we have to tell visitors not to smoke, because we have had fires here at Griffith Observatory too. So obviously care is needed, especially in a season like we had this year. Now it's not just the fires, but the smoke from the fires blanketed the United States. You know that we've had terrible air quality issues in the last month because of the Thomas fire.
Right, and which started early last month, and has become kind of overshadowed the Napa Valley fires, the biggest fire in Southern California history.
In all of California history.
All of California, yes. Yeah. And if we go to the next...
Recorded. I guess, is that... Yes. History, yeah.
Yeah, and again, the big problem with this fire was because we had Santa Ana winds blowing for about a week, which made matters worse. You can see how the smoke's blown out into the ocean in the southwest direction. And if we look at this picture, this is a picture taken by satellite. All that brown area that you see there are the areas that have been consumed by the fire. And as you can see with the spot right here, this represents about 440 square miles of Ventura County area burnt, almost about the size of Los Angeles.
So then lastly, Earth was not to be left out of its exciting extreme, so we had some big earthquakes. We had a huge 3.5 earthquake in September. Does everybody remember that? Okay. Well, I do. But anyway, that wasn't the biggest by any stretch. Just around a few weeks earlier, there was an enormous earthquake off the coast of Mexico, the largest earthquake of the year. And then 2 weeks later, another very powerful earthquake in Mexico. So they really got hit hard. So did Iran, so did Papua New Guinea. But interestingly, this was actually many, many fewer earthquakes this past year than in the last 15 to 20 years. So I know it seems like we were hit heavily with a lot of extremes, but not so bad actually on the earthquake scale. Now, going to something completely different, it was a big year in astrophysics because of some of the discoveries from LIGO, the Laser Interferometer Gravity Wave Observatory, that saw gravity waves coming from a number of merging heavy objects. There were 3 new black hole mergers announced this year. LIGO made huge news last year when it found the first ones, but now there are 3 more. Our statistics are building up. A third interferometer, a third instrument was brought online, and the first, to show you, the first neutron star merger was found, first optical counterpart was found, confirmation of a theory about the source of many elements, and of course, just to top it off, why not, a Nobel Prize for these guys. So these are the masses of the new black holes. You can see anything that has a 17 right in front of it as its first 2 digits there is from this year. So very exciting to get more data. The Virgo telescope came online. What's so important about that? Well, it's exciting because now that there are 3 of them, you can localize the direction of your merger, of your black hole merger. Prior to Virgo coming on, like those big stripes, that blue and orange and pink stripe, you could only sort of get a sense of the direction in a long swath of sky where that merger might have taken place. With the third one, you can see the 2 ones that are labeled 17 there and there. They have only little tiny areas, tiny patches of sky now because you have 3 to localize it, to triangulate. So what was really exciting about this then is we knew where to look, or more or less where to look, and found the first optical counterpart of a merging system. And in this case, it was 2 merging neutron stars, not black holes. But what's particularly exciting about this is that a couple of years ago, there had been a theory that made the prediction that if you see that merging neutron stars should produce gold and platinum and basically all of these elements that are in purple. If you see merging neutron stars up there, all of these elements in purple are theoretically supposed to be the product of these kinds of mergers, and observations from that merger, since we were able to localize it and get telescopes to look at it and look at light coming from that merger, confirm this theory. So it was a huge, huge story, one of the biggest stories of 2017. And then lastly, looking back, there were a lot of exciting advances in space exploration and launch services.
Yeah, well, actually this year, the United States, for the first time since 2003, had the most launches of any country. We had 29 launches. Russia came in second with 20, and that's quite a big thing. What's especially impressive is that a lot of this was due to SpaceX, which had 18 launches out of the 20 planned launches, but there's a few still waiting to go. But that's really picked up the pace of U.S. launching. Now, the whole purpose of, one of the things SpaceX has been dedicated towards is reusability as a way to lower the cost of launching rockets into space. And that was achieved this year a number of times. Here's the first booster used in April 2016 to launch a payload to the space station, was used this year to launch a communication satellite. And then we'll see these same boosters land, is how they're reused. So the booster landing there on the left was reused for this year's launch. And also the capsules now are being reused.
So you can, if you need a launch, you can go to bargain prices from crazy Elon's used rockets.
That's right.
And maybe you'll get them to play the
maracas.
Maracas. Thanks.
Now, also the mysterious X-37B, which the Air Force sends up every now and then, had another mission of more than 400 days in space, and we have no idea what it did. Another little space plane called the Dream Chaser, which is now contracted to send cargo to the space station in 2020, and at least 6 flights, had a successful landing test in California at the Armstrong Space Flight Research Center. at Edwards Air Force Base, dropped from a helicopter. Virgin Galactic is still moving ahead with plans of carrying passengers to suborbital space on their Spaceship Two, and has started resuming drop testing of their Unity spaceplane. And finally, Blue Origin had a spectacular flight recently with their New Shepard 2 capsule. This is a passenger capsule with huge windows that'll allow you to have a couple minutes of weightlessness about 60 miles above the Earth before it automatically lands itself. And this had a passenger mannequin Skywalker. Also carried a number of experiments, including fireflies. Students got to see if fireflies light up in zero gravity, which they did. So.
Also, another record broken. Peggy Whitson, NASA astronaut, now has the longest duration, most numbers of days in space at 534. She also holds a bunch of other records in terms of the duration that she's been in space and her spacewalks and so forth. Long list, but in particular fun this year, big record break, was to now become the NASA astronaut with the most number of days in space. And speaking of people in space, we have to always, say our acknowledgement of Mark Vande Hei, who has, as we mentioned earlier, come twice. If you want a picture of his signed, we have those. If you've guessed the song, he's up on the space station right now, and he comes back, I think, in March.
I think that's right.
Yeah. So very exciting.
So in exoplanets, there was a lot of new news, which was pretty great. The Kepler spacecraft continue to find things. In fact, I don't think the Proxima Centauri one was Kepler. I'm not remembering who did it. It's pale red dot.
I think it's European Southern.
Yeah, it was ESO. But it is the closest star to us. Actually has a planet that might be habitable, so that was pretty cool to find. The TRAPPIST-1 system, it was a system with 7 planets within it, which is all pretty cool. In fact, 3 of them are within the habitable zone. Little faint red star. They're so close you could go planet hopping from one planet to another. You could probably see them in the sky of one another. I love that people came up with names of them. My favorite were a throwback to the old Disney, Bashful Doc, Dobie, or Seven Dwarfs. The Tau Ceti system, Tau Ceti is the closest star like our sun to us, also has planets. We thought back in 2012 it might have some, but in 2017 they confirmed 2 of them, threw 2 away, and found 2 new ones, and a couple are on the border. What's interesting is the Traveler from Star Trek was actually from the Tau Ceti system. Another faint red star, a lot like the TRAPPIST one, Ross 128b, was found to have a planet around it and about the right place for liquid water. However, the Ross system's a little more interesting than the TRAPPIST because the star's calm. These faint red stars tend to have a lot of flares and fry their planets, we think, but this one was a calm one, so maybe a place to go looking for life. In 2017, we found not quite as many planets as we did in 2016. As you see, the number's way down, but still quite a few found, more than 100. Our planet count keeps going up, and I said I was going to get that number memorized, and I forgot to grab it, but you can see the total number of planets. Let me read it off the graph here. 3,000, 1, 2, 3, 4. We're way up there.
Looks like 3,600
It's
or
36 something,
Yeah.
and I don't want to give you the exact number because I'm forgetting it.
And
but
it'll be changed in a few days
it
anyway.
will.
It'll get higher.
Like every 3 days, I'm sending our systems people, can you update our planet count down at EPSA space? But we just keep finding more and more of them, which is absolutely fantastic. Here they are, their orbital periods, how long they take to go around their star versus their size. If you were at 300 on the x-axis and 1, that's where Earth would be. Well, there's not a planet there yet. We're still looking for an exact analog to Earth. But we have found systems that have 8 planets in them. I'm going to tell you about that in the second half. But many of the systems have multiple planets. Lots of them we've only seen 1 planet around. It doesn't mean they don't have more. We just haven't found them yet. But lots of interesting stuff in the world of exoplanets. We did have a visitor from another solar system come visit us. This Oumuamua, however you say it. I can never get this down. Anyway, it was a rock, we think, or maybe an icy object coated with debris that came from another solar system, came flying in and flew right back out. It was about 6 times longer than it is wide, we think. which made us think of maybe solar surfboard, or maybe a modern throwback female one, which is fun. And we had a special guest that told us all about that, which was great. So
And I encourage you
exciting
to
things.
see that video on our YouTube channel. It's a really
Yeah.
good video, and our guest last month told us all about his analysis of this object, Dave Jewett from UCLA.
Yeah, we had a lot of great guests.
So, in fact, speaking of that, we had a lot of great guests.
Be my guest.
Yes! Yay! So Dave Jewett, lower right there, told us all about Oumuamua. Anybody know how to pronounce it? Oumuamua. Okay. Tim Russ came, Linda Spolker, Amy Mainzer. Two more I just want to say, and second from the left on the top, Matt Gollenbeck is the scientist in charge of running the process to select that Mars mission landing site that David was talking about earlier. His video is also on YouTube, really, really interesting if you want to learn more about that. And then David Grinspoon on the left is going to be back. I believe it's in May. Because he and Alan Stern, also a friend to the show, has been on All Space Considered before, a guest from the previous year, and principal investigator of New Horizons. And they have a book coming out, so they're going to come and do a book tour talk and a signing. I think it's going to be on a Wednesday. So we'll obviously let you know. Keep looking at our website and our Twitter feed.